one's hard. I typically find paradox questions to be the easiest to predict, but this one is pretty, I feel like it's pretty challenging. Like there's not like an obvious, oh, this would solve it. But at least there's an obvious paradox of the two facts, right? So it says the effects of global warming on the polar ice caps have been studied with computer models. Cool, just background information. According to some, so at least one model, if the global temperature increases by as little as 2 degrees Celsius, the seawater will rise to a temperature that could melt the ice caps considerably. So we're saying if it goes up, the seawater will rise and will melt the ice caps. However, these models also show that under such a scenario, the volume of the ice caps would increase, not shrink. So Sabrina, what is our two facts here?
So because the global temperature is increasing, we're saying the seawater will rise in temp and then that will melt ice caps.
Yep,
But
so
then
the ice caps could melt considerably.
And then on the other hand, though, we're seeing that the volume of the ice caps was increasing and not shrinking.
Excellent. So it's like, how could the, so what we're trying to predict here is, how could the ice caps be melting, but also be increasing in size? Did anybody have a good prediction here? I'm gonna see what you guys, no clue, but perhaps the inside of the ice cap melts, but outside grows, making it larger, but not as dense. Oh, like you're thinking like it's like sludge instead of like frozen ice.
Hollow inside, but like getting bigger on the outside. I don't know.
Sure. No. Okay. The reason that I love these predictions is at least you are truly focusing on the two facts. The number one, well, maybe not. I'm just going to make up my own statistics here. But a major reason why people miss paradox questions is because they don't focus on the two facts that are actually contradicting each other, and they find an answer that only addresses one of them. And I'm still like low-key just trying to highlight the two facts. Okay. And then Sabrina said, hail is happening and sticking to the ice caps, so they are not, yeah. So they're melting, but hail is coming down at the same time and replenishing them. Perfect. I love when like I don't know a lot about a topic, and if someone else, like if some maybe not environmentalists, but whoever would be in this field would hear our explanations, would be like, that is so unrealistic. You're like, you know what, that's not the goal. All right, so go ahead and read through these answer choices and put your answer in the chat, and then which ones you were debating in parentheses too as well in the chat. I feel like this is a great question of practicing paradox and focusing on our two facts. And if it doesn't addressing it, moving on. So let's go ahead and start with E, where it says, as global temperature increases, more seawater, and also for all of these, like it all kind of started the same. Did anybody else like have to like picture this in their head and like kind of get it going to like kind of even visualize it? I'm a very visual learner, and that's what I had to do. So I was like, okay, as temperatures increase, more seawater evaporates into the atmosphere, thereby leading to increased cloud formation, which causes smaller variations between the average temperatures of the Earth's hottest climates and those with the coldest climates. Why did you cross this one off, Alicia?
I just didn't think it addressed the issue of why the ice caps are reforming at all.
Yes, I kept going back to, my thing kept going to like, we have to have the ice caps melting and we have to have the ice caps staying the same. And so the fact that my issue with this one is like, if there's smaller variations, I was like, okay, then why is the ice melting, not melting? We don't know. So I didn't like E. D says, as seawater temperatures increase, evaporation of seawater causes the concentration of salt in the water to increase. All right, we got more salt, which thereby lowers the temperature needed to freeze the seawater. What was your issue with this one, Sabrina?
I guess it only addresses one of the two.
Yes. So I'm like, okay, it lowers the temperature needed to freeze, but I'm like, but then why is the volume growing? Mm-hmm. Like, if we have a lower temperature to freeze, wouldn't it not only melt considerably, but even more considerably? So I don't like that. So I crossed that one off as well. C says, as sea temperatures increase, the difference in temperature between the polar ice caps and the adjacent water becomes greater. So the temperature difference between the ice caps and the water underneath it becomes greater, which in turn causes the water to melt the ice it contacts at a faster rate. What is our issue with this one, Alicia?
It kind of saying is the opposite of what we had said. We're saying that the ice caps are increasing, and here it says that they're melting at a faster rate.
Yep, I too. I'm like, why are we growing? Excellent. All right. And then Sabrina was like, A, B, A, B, A, B. Okay, so let's look at B. As global temperatures increase, more seawater evaporates into the atmosphere, thereby lowering the ocean level. I'm like, okay, so we have more water going into the air and lower ocean level, which then results in less contact between the ice caps and the warmer water, thereby stabilizing the size of the ice caps. What is our issue here, Sabrina?
So I guess it stabilizes the size of the ice caps rather than the volume of them increases.
Excellent. Look, details, details, details.
I know, I wish I just saw that when I took the actual test.
All right, and then A says, as global temperatures increase, more seawater evaporates into the atmosphere, thereby leading into increased snowfall at the polar caps, which then melts and refreezes as ice. So I feel like this really goes into like those, like, it's like a more crazy cycle. It's just like more intense. It's like melting snow, growing worse, more, yeah. And so that's why our answer is A. Do you feel confident about that?